today we're going to start a unit on functions, so I thought maybe you would like to know what a function is. Before we talk about functions, we need to talk about something called a relation. A relation in math, anyway, is a relationship between two quantities. You've seen it a lot of times this year as ordered pairs. So here I have the height of 5 giraffes, the age and height of 5 giraffes. I've taken each giraffe and put their age and height into ordered pairs. This is a relation. So two more vocabulary words that are hugely important and should go in your notebooks are domain and range. The domain is a set of first coordinates in ordered pairs. Now notice when I wrote this set down, I used squiggly brackets, otherwise known as braces. Okay, I put a D for domain, and I'm going to list all of their ages in order from least to greatest, no repeating. So the two 18-year-old giraffes, I don't write two 18s. One 18 is enough just to know that there's an 18 in my set. Notice how they're all the x values, right? That's why I wrote down the x values only. The range then is the set of second coordinates in the ordered pairs, or y values. So I took all the y values, I put them in order from least to greatest. Again, use the braces and put r equals so I know it's range. So take a look at these ordered pairs and make sure that you understand why I wrote down the domain and range like I did. So one more definition for today. A function then is a relation that assigns one value in the range to each value in the domain. In other words, each and every x value can only be assigned to one y value. That makes our giraffe data not a function because I have two 18-year-old giraffes that have the same height. This one x value, right, has two different y values that are assigned to it. So this would not be considered a function. Functions are kind of like playing a fair game or having a fair bill. If you played football and both teams scored 3 touchdowns with extra point, would it be fair if one team earned, let's say, 50 points and the other team only earned 14 or 21? That would totally not be fair. That would not be a function. Or if you had the same cell phone company and the same plan as your sibling, talked for the same number of minutes, or had the same amount of text messages, would it be fair if you had to pay $80 and your sibling only had to pay $10? Again, it wouldn't be fair, so it's not a function. A function says every person that has the same cell phone company, same phone, same plan, and talked for the same number of minutes should pay the same amount. So here my ordered pair, my relation looks a little different. I've got it in a table. I can create ordered pairs out of that. The domain, again, is all the x values in order, least to greatest, no repeating. The range is all the y values in order, least to greatest, no repeating. This is a function because every x value only has one y value assigned to it. Take a look at this one. Do you see in the table how I have two of the same x value? And at the same time, that 3 is assigned to a 7 when it's also assigned to a 1? That is what you want to look for that makes this not a function. The two 3's are assigned different y values. That's exactly what we don't want to have happen. There are other ways to show a relation. I want to show you something on this graph. We can use a vertical line, this is called the vertical line test, to see if this is a function or not. Now, right here, for instance, that point has an x and a y. This point has an x and a y. The x value of 2 is only assigned to the y value of 0. But, oops, moved the wrong thing. What happens when I move my vertical line right here? Do you see how this x value of -1 is assigned a y value of both 0 and 3? That makes this not a function. So sometimes you can use the vertical line test to check and see if you have a function or not. These ovals down here, that's called mapping. So we're actually going to change that word right there from circles to mapping. Now, in the first circle is my domain. Normally, I would put that in order least to greatest. In the second circle is my range. Every arrow that goes from x to y represents an ordered pair. So from 4 to -3, that's the ordered pair 4, -3. This arrow that goes from 2 to 7 is the ordered pair 2, 7. So is this a function? Are all x values only assigned one y value? The answer for this one is yes. What you want to watch out for is if you have more than one arrow coming off of any x value. Is this a function? Absolutely it is. Let's talk about domain and range really quickly. If this line goes on forever in both directions, every x value on the grid is going to be involved. So my domain is all real numbers. Same thing with the y. Every point on this line has a y value. Every y value in existence will be part of my range. This one's a little bit different. This one is a function. Every x value is only assigned one y. The domain, this is going to continue to go up and out in both directions. Every x value in existence is going to be on that line. So my domain is all real numbers. The range, however, notice how none of the negative y values are included on this graph. So my range starts at 0 and goes all the way up to infinity. So I can say from 0 to infinity. I can also write it as an inequality. Let me turn this back on so I can actually write. I can also write it from 0. This is range, so I'm going to talk about y. That's less than or equal to is less than infinity. This means that y goes from 0 to infinity. How about the following one? Why is this not a function? These two arrows that come from the 2 is being assigned to 4 and 5, makes this not a function. The 2 arrows pointing to the 5 in the range absolutely has no bearing on whether this is a function or not. Writing the equation in function form simply means isolating y. We're just going to change to slope-intercept form, and that's considered function form. I start with the equation 8x plus 2y equals 32 in my example. I subtract the 8x to the other side and divide by 2. When I get y equals -4x plus 16, now I'm in function form. Looks familiar, doesn't it? Let me know if you have any questions. I know this was really fast. We went way slower in class, but make sure to write them down so you don't forget to ask me. Your assignment to go with this is the Introduction to Functions worksheet. Good luck!